Once I stop sharing, you can share your presentation, sir.
Okay.
We will wait for a few minutes.
Okay.
Slowly participants are coming. Maybe we can start at 3:35.
Okay.
Okay, sir. Mamamati sir, slowly we'll start. So good afternoon to all of you and welcome for the afternoon session. This session is going to be the final session and the most important one, because here we'll be discussing about the various challenges posed by expansive soils and what are the various foundation alternatives we can think of with regard to both shallow and deep, right? So this topic will be dealt by Professor V. Ramanamurthy of NIT Warangal. So before he delivers his lecture on the topic of foundations in expansive soil, I'll give you a brief introduction of him, though most of you may be knowing him. Professor V. Ramanamurthy is presently working in the Department of Civil Engineering at National Institute of Technology, Warangal. So he has a teaching experience of 23 years. He obtained his BTech degree from Nagarjuna University and then obtained his MTech degree from JNTU Kakinada, and subsequently pursued his research in so-called Regional Engineering College at time, presently NIT Warangal, and he obtained his PhD degree from NIT Warangal, and after that he has joined the same institute, NIT Warangal, as faculty member in 1997. Since then, he is with NIT Warangal, and presently he is serving as a professor in Department of Civil Engineering. He is member of various professional bodies like ISTE, Indian Geotechnical Society, Indian Society of Rock Mechanics and Tunneling Technology, and he is recipient of several awards. He received Meritorious Educational Excellence Award from Global Society for Health and Educational Growth, New Delhi in the year 2003. And he received several papers, best paper awards, right, in IGCs. He has received IGS Sri Dasidar Biennial Prize for the best paper on ground improvement for the year 2002-2003. And then he has again won IGS Sri Gupta Biennial Prize for Best Paper on New Approaches and Techniques for Analysis and Design of Shallow Foundations for the years 2004 and 2005. And then he bagged again IGS Sri R.N. Prasad Biennial Prize for his paper on slope stability and landslides for the years 2007 and 2008. He is recipient of the Corps of Engineers Prize from the Institution of Engineers India for the period 2008-2009, and his technical paper entitled Piled Footing, an Alternative Foundation System in Expansive Soil. He is recognized as one of the most popular publications from India during 2015 by the Institution of Civil Engineers, London. Till date, he has more than 80 technical publications to his credit. They are published in highly reputed national and international journals and proceedings of the conferences. He has guided two PhD scholars so far. They are awarded, and he has guided 46 MTech dissertations. Right now, several research scholars are working under his guidance for their doctoral programs. He has completed a research project on high quality, low cost ferrocement housing sponsored by MHRD New Delhi. He has organized several workshops, to name a few. A 2-week MHRD sponsored short-term course on ground improvement methods in problematic soils in 2001, workshop on geotechnical engineering in practice in 2012, workshop on georisks and remedies in 2014, and he has conducted a GIAN course on ground improvement technique with Professor Hemanta Hazarika from Japan as foreign expert in 2016, and he has organized 5-day faculty development program on effective teaching of geotechnical engineering from 2nd to 6th January 2017. And more importantly, he is the key person behind the successful organization of Indian Geotechnical Conference 2004 at NIT Warangal, which some of you might have attended. It is very well organized. He is consultant to many organizations, many state and central government organizations, and local bodies. His prime area of research is in expansive soils. He has published high quality papers in expansive soils. Not only his area is confined to foundations in expansive soil, he also deals with payments in expansive soils and other areas of ground improvement. So, he moreover he adds philosophy to his teaching. At the end of his presentation, right, you will be able to appreciate, right, that. So, with this introduction, I invite Professor Ramanamurthy to deliver his lecture. Please, sir.
Sir, it seems you have to give permission to share, is it not?
Yeah, I'll do that, sir. I'll stop presenting. Okay, sir. Now you can present.
Good afternoon, my dear participants. Let us have, it is like not one-way teaching. Let us have some deliberations also so that clarifications will come out of it. Foundation techniques in expansive soils. In fact, most of the civil engineers claim that expansive soils are problematic, but truly speaking, by themselves, they are very healthy and active clays. But because they are giving some trouble to our engineering structures, we are blaming them. Otherwise, these clays are only our life. That slowly we will understand, and how to come out of this problem and address our own civil engineering problems, we will see. Let us see the source of problem and solution here. Normally, any soil, the three-phase system will be shown like this only, even for conventional soil or expansive soil or black cotton soil. In this, as a civil engineer, what are the general problems? In case there are more voids within this system, it can undergo settlement. To that extent, we need to compact either by shallow compaction or by deep compaction. In ground improvement, we all have studied that. In case it is fully saturated, in that situation, the drainage may become a problem and effective stress may be at risk. To that extent, we have developed the hydraulic modification techniques, dewatering. For different types of soils, of course, different ways of removing water. All soils do not listen to one technique, right? In case of clays, you need one technique. In case of sand, simple pumping is enough. In case of fine sand, you have to apply some vacuum. All those techniques we have studied to that effect. Solids, see, the term is misleading. Solids are not solids always. Healthy solids, problematic solids. Morums and all other conventional solids are okay, except this clay solids. Clay solids, truly speaking, they have life. That is why they show activity. They respond to the environment. Sand, for example, neutral particle. It always remains silent. Then there is no life also. It cannot support life. We have to be very clear. So then, the problem that is arised in this clay is like this. How clays are formed? Clays are formed out of intense chemical weathering. Ultimately, the particle size will be reduced to 2 microns and less than that. When the particle size is reached to such a fine state, again, peculiar mineralogy is created by nature. Those mineralogy is clay minerals, montmorillonite, kaolinite, illite, chlorite, so many clay minerals are formed. These clay minerals show a tremendous degree of activity, especially the montmorillonite. In that case, the problem here you see, as long as the water is only in the pores, your effective stress principle given by Terzaghi is all right. As long as these solids have additional attraction to this water, then this effective stress principle alone is not sufficient. If you eat for hungry, it is all right. If you eat extra and you are craving for extra food, obesity is the result, is it not? Same way, here also these solids do not satisfy with the water that is present and filled in the voids. In addition, they have extra craving. Little later we will see where from this craving for excess water is arised. Yeah, of course, Terzaghi, he has shown us the way to understand the mass. Otherwise, soil is like a lump, nobody can understand. He has given us a torchlight in the form of effective stress principle through which only we are able to understand this mass. Here, let us understand the same footing in conventional soil and in clays, how they are different. In case of conventional soil, if you construct a footing and load it to say some load P, at the most it can undergo some settlement. When water goes, okay, it will saturate and fills the voids. There ends the matter. If at all it is sand, strength reduction is almost nil because angle of internal friction, whether it is fully saturated or dry, sands do not show any change in their angle of internal friction. At the most, only density will be lost a little in case it is submerged, except that there is no problem. But in case of clays, some capacity can be reduced because of the plasticity. Up to that also okay. But in case of expansive soils, now see the problem. Under the same conditions, when water is entering into this soil below the footing, it is able to lift the footing. Here it is settling under the load. Despite the load present here, it is able to lift the foundation. Water, if in the three-phase diagram, if we look at, all the strength comes from the solid phase only. Neither water nor air really have any strength. They cannot contribute any strength to the system. All the strength comes from the solids only. But here, the entered water is able to lift the foundation. How then the water is getting strength? Peculiar, is it not? Water should not have any strength as per that. Here, the whole philosophy is these expansive soil particles have tremendous attraction for this water, and once the water is sucked in, it cannot go out. That is the amount of suction this soil exerts on this water, and it increases its volume by absorbing this water and lifts the foundation. Even in terms of effective stress principle also we can nicely understand, as long as this pore water pressure is under suction, it is a negative. So effective stress is equal to total stress minus of minus U. It becomes plus. So that means during that swelling process, the effective stress is increasing here. That way also it is getting more strength during that process. But once it is fully saturated and lifted up, once again the strength reduction takes place. That is the problem with these expansive soils. Volume change takes place, and this volume change normally either settlement or heaving. In civil engineering, only 25 mm differential is allowed. Otherwise, beyond that, our structures will be subjected to cracking. Now let us see the mechanism, how then this water is gaining strength. That is what just now I have referred. All soils will have some quest for water. That is in the form of matrix suction. Because soils are particulate, I think one Hello? Hello?
Sir, tell me, you are
Ah,
audible. You are audible.
sir, my video is off, I think. Na?
No, it is coming. It
Coming.
is slides are moving also.
Okay. Okay. Okay, then it is all right. So here, these negative charged particles will attract the positive ions, and once these positive ions are attracted, don't think that this positive is really positive. They also have their own affinity for water. This energy also will be satisfied by again negative energy. That means anions again will be attracted. If anions are not available, more affinity for water will be there. Truly speaking, all cations have their own affinity for water. That is what is called cation hydration. That means negative charged particle, positive ions were attracted to satisfy its own problem. In turn, these positive ions are holding the water molecules on their surface. Okay, this ion is his guest. Again, these guests are also his guests. Ultimately, here a big samsara will be formed, so that the concentration of the ions will be increased compared to the outside environment. Normally, in nature, imbalance is not accepted. Once the imbalance is created because of the excess cation hydration in between the two clay mineral particles, additional water will enter into this zone, try to neutralize this energy. Then that is what is called osmotic repulsion. That is only reflected in the form of our swelling and swell pressure. That is how, friends, the swelling is originated from the negative charge. Little later we will see where from this negative charge is originated again. Then in the field, when we are taking up projects, we should identify these soils. How can we identify? Sometimes we may confuse also. Don't think that all cracks are only belonging to black cotton soils. So that is why this cracking also distinct in case of black cotton soils, just like map we can see. Then we can suspect their presence. And especially when they are wet, if you are walking in any conventional soils, a little mud can stick to your shoe. But in case of black cotton soils, the thickness of the clay that could be attached to your shoe can be up to half a feet. That is possible. That is why stickiness to the tires and shoes when wet. Difficulty in breaking dry soil pad between fingers. This is all because the black cotton soil during its shrinkage or drying will be subjected to a suction pressure or desiccation stress in the order of 100 to 150 ton per meter square. That is why only during shrinkage test, what all the density the pad attains by simple drying, you and me cannot give it by any amount of rolling. That is all because of the capillary stresses. High order capillary stresses will work on the soil particles and simply press them to the best of their density. Here also the same thing, when that is subjected to 100 to 150 ton per meter square pressure during this desiccation, what after all our fingers could exert. That is why it is very difficult for us to break these pads of clay between our fingers. That is also another sign. And 3 to 5 mm diameter thread, even 4 to 6 centimeters long, could also stand vertically. Then soil pad, when molded with hand, and of course dial density test we will see in our soil mechanics also we taught between the silts and clays. In case of silts, the moment you saturate and shake it, shining surface will appear. But in case of clays, that does not appear because the water cannot flow easily in and out. That is also another sign. That is why they do not show any shining surface. Presence of severe cracking in the buildings, roads, canal linings, etc., also a sign of their presence. Okay, quality control, etc., is a different issue. Here the cracking will be distinct. Little later we will see how worst the cracking it could exert on our civil engineering infrastructure. Of course, generally in black cotton soil areas, the ground will have a mild slope only, less than 20 degrees. Yeah, this is how the ground can break even up to 3 meters depth. This cracking could extend. And truly speaking, this type of shrinkage cracking is healthy for cultivation. Agriculture scientists say when this ground breaks like this, any of the unwanted materials can be oxidized and neutralized, and it will be fully aerated. So that is why this clay can remain healthy for a long time. That is how this type of behavior is appreciated in cultivation or agriculture. But in case of civil engineering, only the trouble starts. In case any of our infrastructure, especially roads, for example, if you construct on these soils, simply it cracks, and the road material, what all we place, base course, sub-base course and all that, they are also after all aggregate and soil only. So they also crack. Ultimately, this crack can be reflected to the surface. That is the problem. That means our pavements can simply break like glass pieces. Yeah, this is how the cracking distinctly in the form of map, it appears on the surface. So any other soil also can have cracking, but not this intensive. That is how we can identify their presence. And of course, exactly based on the testing, we can confirm 100% mineralogical identification. Identify the mineral. If it is montmorillonite, definitely it is expansive soil. In case this is not available, we can still depend on Atterberg limits. Liquid limit, if it is more than generally 50%, and differential free swell index also we will do if it is more than 100%, then we will immediately suspect the presence of these soils, right? Suction also, if it is more than around 300 kPa, see normally the suction between the clay minerals can be even up to 1000 kPa. That means tremendous thirst will be there between those particles. That is why only they could attract water and hold it against the load also. And ultimately, despite the load present on the foundation, these soils could lift the foundations. So instead of indirect methods, directly also we can measure. That is what we do in our consolidation test. Keep the specimen, allow it to absorb moisture, measure the volume change, and once it is fully swollen, once again load it to bring back to the original volume. Whatever the load that is required to bring back the swollen sample to the original volume is referred as the swell pressure. This is most commonly used method called free swell method. That gives both the volume change and also the pressure that could be developed if you suppress the volume change. Yeah, this is what we were referring. High liquid limit and low shrinkage limit, suction, all these are the measurements. More suction means more affinity for water. More affinity means more damage. That is how we have to be clear. And of course, swell tests. Difference free swell index is easy. 10 grams of soil passing through 425, we will place in 100 ml distilled water, and similarly in 100 ml kerosene, difference in volume divided by original volume, all that we can measure. If at all it is close to 100, again we have to be careful. This is what now I have just now explained in consolidation test, swell potential and swell pressure. Under 5 kPa surcharge, it is allowed to swell and again consolidate it back to its original volume. And even by simple index Atterberg limits, using this plasticity chart, one can plot the point. See A line, other Casagrande line. This is again another line is given U line. D points for black cotton soils will fall within this band between A line and U line. U line equation 0.9 into liquid limit minus 8. Here it is already known to everybody. And this is another chart given based on the activity of the soils, clay fraction and plasticity index. Depending upon this, in whichever the band, see these are all divided into different bands. If you ever, suppose for example, if it is falling here, it is high band, medium band, low band, all that is already mentioned. So easily one can identify the swelling nature of the soils. And you see, different authors have given their own way of identifying these soils, but of course, there are several overlaps. Despite that, we can still have an idea. Okay, so here just now we have said shrinkage limit less than 8 is very critical. Here also the similar values, except with one or two, they will say here 10 is written, except that no problem. So okay, critical. Then here it is from America again. They have taken multiple parameters. Colloidal means clay colloids, especially if clay colloids are close to 30%. Shrinkage limit is just less than 10. Expansive soil, blind rule, right? So we can suspect, understand, measure the soil pressure. Accordingly only we have to design the foundations. Then of course, based on the activity is plasticity index by percent clay. If it is more than 1.25, we can suspect high degree of expansion. And again, ASTM also has come out with the expansion index under 1 psi load, just like the consolidation test only. Here it is 1 psi load is suggested and allow it to swell, measure the expansion index. If it is close to 100, you see high degree of swelling. Though, so as an engineer, though it is difficult to remember all these tables, that 100 you can remember at least, differential free swell or this expansion index, liquid limit more than 50 to 100, all of them are critical. Later we have to confirm. Then of course, you see here suction, just now I was referring, more than 300 is very high. See, it is given by this Snathan has given this value. When the suction is more than this, the soil can show high degree of swelling. Please understand, by itself, the value will not reflect. The whole problem is expansive soils, despite their problem, if you can protect them against the environmental changes, then also they will sleep silently. The problem starts only when the environment changes. Okay? So that is what we have to understand. By itself, it may be having high degree of swelling. If the environment is not conducive, it doesn't show its effect. That is why such foundation techniques are also available. Little later we will see that. That is why after understanding these fundamentals, we have come out with some ideas how to nullify them and how to silence them. And here, of course, Professor Sridharan, instead of kerosene and again water, he has given directly with only water. For example, you see 10 grams of oven-dried soil passing through 425, we have placed in 100 ml jar. He has given this in measurement, you see. If at all it is 4 cc per 1 gram, then the degree of swelling is very high. Okay, that means if at all that 10 grams of soil becomes 40 cc, then it is very high. Or in between about 3, then it will be high, something like that. One can directly depend on this only instead of kerosene and all that. Of course, he has given this not simply to avoid kerosene, but the scientific background for this is that minerals like kaolinite, etc., they have their own affinity for the kerosene or carbon tetrachloride. So in order to overcome that problem, wait, invite a problem and again understand, he has suggested just avoid it, directly measure it like this. Okay, it is also a nice suggestion. And of course, IS classification is also given for the degree of swelling. Just now I have said the liquid limit close to 100, see, severe. This category is coming under severe category. And free swell index greater than close to 100, critical. More than 200 means very severe. So 100 we can remember at least. Liquid limit close to 100. differential free swell close to 100, shrinkage limit less than 10, generally indicate the high degree of swelling. Yeah, these are all some of the failures across the world since 1936. He is from Burma actually. Yeah, this is from India only. Then this is also from India. So many failures across the world. It is myself in Warangal during my PhD. Some of the photographs we have taken of the cracked walls in black cotton soils. Yeah, even pavements also will be subjected to severe cracking like this. Or you see, during shrinkage, long snake-like cracking is possible. Once this type of cracking is occurred, rainy season comes and water enters, and ultimately the underneath clay becomes slush and mud. It will again be pumped out. So pavement distress will be highly accelerated. So this is the problem with this type of clays present below the pavements. Yeah. In case of monsoon, the same clay can become like this. Is it highway or mudway? So friends, despite all this, using the technology, we can silence these soils. Otherwise, it seems very difficult, is it not? But silently, if you understand the mechanisms, you can use that technology and silence these particles so that they do not show this much affinity for water. How they are becoming like this slushy? It is only because these particles are able to hold a lot of water. The sand, gravel do not attract water, but these particles are attracting water. Right? That is the very problem. Of course, that is only the source of life. I have just now already said. At clay mineralogy, you will see the philosophy behind all this. Yeah, these are some of the failures even for the canal linings. Crores of rupees can be, we may lose because of these losses. Yeah, this is again Kakatiya Canal passing through Warangal city, and it is peculiar. It is from Sri Ram Sagar project, 280 kilometers, only near Warangal, I think close to Kids Engineering College, for 100 meters long, severe cracking we have observed. And to my surprise, the clay behind, when we have tested, the differential free swell index was around, I think, 700%. Very peculiar. Only there. Beyond that, it is not there. And of course, for such a high degree of swelling, CNS layer technique is only available in case we do not want this type of failure. Maybe it is better to supplement two techniques, like first silence the clay using some lime or calcium chloride, something like that. Then you put the lining, CNS layer, then lining. Otherwise, again, 700 DFS means merely CNS layer also may fail. In fact, here also CNS layer was provided. Despite all that, this is the failure. Here, normally retaining walls are designed, we all have studied in our UG or PG courses, half Ka gamma H square. That half Ka gamma H square does not stand when black cotton soils are present. Here, we should be wise. Behind this retaining wall, here or here, you see the wedge is formed, sliding wedge. At least that wedge portion must be filled with good soil. Otherwise, again, this will be a problem, right? Sometimes people normally, they do not understand. Only behind this wall, they place a half meter to 1 meter gravel or good soil. Immediately after that, again, they will place the black cotton soil. Then it is a failure. Okay. So here, by the time that CNS layer theory philosophy arises, this clay can simply push the wall, and lateral swell pressure can be 10 times that of the vertical swell pressure. Professor Katti reports, it is again peculiar. The same clay is highly anisotropic in terms of the swell pressure development. What all the swell pressure we measure in our conventional consolidometer is vertical swell pressure. But however, in the field, in the lateral direction, 5 to 10 times the vertical swell pressure could be developed in the lateral direction. Assume some 2 kg per centimeter square, that means 2 ton per meter square. Then, if it becomes just 5 times, why to take 10 times? 10 kg per centimeter square, that means 100 ton per meter square. Can we design a retaining wall for 100 ton per meter square lateral pressure? It is foolishness to think also. Instead, the wisdom says nullify rather than handling. Whenever something is very strong, the wisdom says don't face it, avoid it. Then that is possible here. We know at 45 plus 5 by 2, the sliding wedge will be formed, preferably at 45 degrees. Forget about that 5. At 45 degrees, if you fill good soil here, mostly you will be free from this type of retaining wall problems. Okay, at several swimming pools, etc. In fact, I myself was consulted, and again we have given the same suggestion. Fortunately, that technique worked very well. When I have suggested to fill good soils at 45 degrees, almost all walls are safe. In fact, there were some failures, and subsequently they could be addressed like that. Yeah, these are some of the failures in Ordnance Factory, Hyderabad. In fact, during 2013, NIT Warangal was asked to give a certification to their campus buildings. In fact, there is, it seems, a norm. As per the defense norms, these buildings are to be certified by institute in every 5 years. So we were asked to do that during 13, and a team of our professors we have visited several times. And it is also very peculiar. The area of this ordnance factory is around 3,000 acres, out of which almost half of the land is black cotton soil, and the other side it is all moram soil. On the black cotton soil area, they have constructed some 800 staff quarters. I think they said it is during 1985, something like that. So subsequently, these quarters were subjected to this. They were almost become non-livable. Okay, see how critical the condition is. All these were simply broken. These floorings, etc. See, that is why we can easily understand how much load will come on each beam. We will calculate in RCC designs, is it not? See how even the nature has demonstrated it. This trapezium and this trapezium, something like that. When it is held and lifted, it is broken like that. And in fact, the doors also sometimes we cannot open. Okay, that is how it has become like. Because of the severe damage, what we have suggested, I think some 200 staff quarters we have recommended for the demolition and reconstruction, and another, I think, 100 staff quarters, little better. So we have suggested a strategy of repair, something like that. So much of problem, friends. That is how. Then the very root cause you can ask, why at all this much damage took place? What they have done, these are all only single storied and double storied, that's all. Loading is very small, so they have simply gone for strip footing. Then this is the problem. In black cotton soil areas, that is why if you simply think it is bearing capacity and settlement like conventional foundations, you will be landed on a problem. Same thing happened here also. The traditional bearing capacity theories, if you apply and design your foundations, ultimately the structures will fail, right? Here, even if you want to go for this type of strip footing, internationally, people suggested to keep gap in between. Then when you are putting gap in between, way to really go for a strip footing, it can be pad foundation plus grade beams. Is it not? That is what we all construct. So that is how again we have refined. Later we'll see how people have thought about all this. Strip footings are not at all advised in the black cotton soil areas. Yeah, this is how we were observing, and yeah, this is again internationally also. We have see normally if you say something, people also may not believe. Then for the same conditions, internationally also you see this figure we have taken from Professor Chen's textbook. He has exactly given below the strip footing only, continuous footing only, the failure. So it is matched. So we could convince to the officials, okay, why we are really suggesting demolition of them. Yeah, here in fact the whole mechanism lies for this type of behavior. Friends, nature is so great, out of great process, clay is formed. Like our blood, milk, clay is one of the extraordinary making by the nature, because it is this clay which supports all the life, bacteria, virus, fungus, through that again all the plants, through that again all the life, animal kingdom. Otherwise, in the absence of this clay, nothing could live in this world. That is why one of the philosophers says the true prosperity of a nation lies in its clay. Simple statement. If not immediately, in the long run, also one can ultimately understand this truth only. The true prosperity of a nation lies in its clay. Then let us understand how at all these clay minerals are formed. All the clay minerals we have come across, kaolite, illite, montmorillonite, chlorite, smectite, oh, so much of all that. All these clay minerals are merely formed out of two basic structural units: silica tetrahedron, and alumina octahedron. These are only the two basic building blocks. This is shown like a trapezium. This is shown by a symbol rectangle. So these arrangement, difference in the arrangement forms different clay minerals, right? For example, our montmorillonite, silica, alumina, silica. The same units will keep on repeating. Okay, silica, alumina. This silica I have said represented by trapezium. This is represented by rectangle. Again silica here. This is one unit. Around 10 angstroms will be its thickness. Similarly, the units will repeat. In between you see it is only water molecules plus cations. That is why the bonding is very weak. Because of this, it attracts outside environment, additional cations, water, everything. This zone is not at all permanent, continuously subjected to disturbance. Because here you see these basic units in nature, normally in this nature, everything will be balanced, but imbalance also will be created. That is how only the gradient will be there, and because of that gradient only everything will keep running, right? That is why one of the philosophers says that the universe is the self-deficient system created by the Lord. Excellent, self-deficient system. That is why only it is running. If everything is sufficient, then everything will be stagnated, is it not? So that is why only that type of imbalance is already created. Here also, for example, silica 4 valency, and here these are all oxygens. Again, they are attached to other mineral particles. So that means 4, and this 4 will be satisfied, silenced. Excellent. Here also the similar arrangement will be there. Alumina inside, and all these also will be shared again. Silenced. By itself it is silenced one. But in nature there will be an attack. This silica can be attacked by alumina from outside. And this alumina can be attacked by magnesium from outside. How this attack takes place? It is something like this, friends. Mass law. Outside, for example, here more magnesium ions are accumulated. One of the magnesium ion in that high accumulation would succeed to push this aluminum out. Here also, the silica can be pushed out by alumina. Here alumina can be pushed out by magnesium. Then what happens? In case if it is aluminum with valency 3 is occupying this position, a net negative charge of -1 is left because it is already 4. Okay, 4 into 2, but again it is sharing. 4 is there negative charge from oxygens. Here 3 only there, that means net negative charge 1 is already created. Same way, here also it is possible. Ultimately, these negative charges that are originating structure reflected to the surface. Please understand, the source is elsewhere, the affinity, the effect is only on the surface. All the plasticity, what all it is showing or manifested on the surface is truly the reflection of this change of the heart. Actually, we could say this is what is called isomorphous substitution. As a whole, this structure remains intact here or here. Only the heart is transplanted. Please see, this internal ions only changed. Everything seems to be nice, but internally the very heart is changed. Accordingly, the stability is lost. Once that stability is lost in the form of charge deficiency, these particles will lose their stability, and in order to restore stability, these particles have to take the help of environment. From nature again, cations it will attract to silence its own charge deficiency. Like our hungry friends, every 3 to 4 hours, it repeats. Okay, he actually hungry is a bless and also a misery. Okay, every time whatever that is repeating gives trouble. Here also the same problem. This charge deficiency can never be totally silenced. That is the problem. For example, here some cations were taken from the environment. Don't think that those cations will permanently stay here. They can again be replaced by even on the surface also. You see, the our politicians can easily demonstrate that whoever follow-up is more, he will win. Is it not? Same thing here. For example, here calcium is present. Tomorrow, if at all aluminum cations are accumulated here, they can replace this calcium fellow. Okay, so then all this will be changed again. To that extent, again, it has to respond, be adjust. Every time it is a problem. And in that transfer, water is only the medium. Please understand, the ions cannot travel in the absence of water. Again, this negative surfaced particles have their own affinity for water also. Just now I have said the cations have their affinity for water called cation hydration. Don't think that they only have affinity for water. The negatively charged clay particle also, along with the cations, has its own affinity for water. Directly also, the water molecules can sit on the surface with the positive end. Water being bipolar, with the positive end, it can sit here. So like that, this negative charge makes this clay particle measurable. All environment, it will accumulate here along with water. As it is under the influence of negative charge current, this water and environment cannot easily escape. That is why when you remold this clay, it only shows the plasticity because of that inevitable water films between the particles. That is how we have to understand, friends. And sometime back, one of our students asked, sir, why it is really made negative? Somehow if nature make it positive, at least it would have been better. Then my ignorant or wise answer was, if at all this clay was blessed with positive charge, maybe it might not have worked to this extent, and this much life supporting might not have been erased. Okay, because life comes only out of great struggle. Okay, Vivekananda. So our mother is struggling, and on the earth, it is inevitable for us to struggle. Okay, so that is how we have to understand, friends. And most of the time, people are also generally outside people claim, be positive, don't entertain negativity. But then as a joke, I say my clay is negative out of which we have all come. And as our mother itself is negative, it is difficult for us to maintain always positivity. Then of course people will enjoy and lifelong we will remember this negative charged clay philosophy. Okay, right then, friends, this is how one can understand. Then the wisdom says, as a civil engineer now, to somehow we have to silence the particles through engineering. There only our success lies. We cannot fight with these particles. It is like coronavirus. What fighting we can make? Yeah, the only fight is we can silence. That silencing is only the answer here also. When the particle size is too tiny, our fighting will not be wise. Okay, we have to be so innovative and silence the system. That is possible in case, for example, what is the problem of this particle negative charge? Then instead of allowing it to search for its own food in the form of cations, as a civil engineer, I can supply the intended cations here. Okay, preferably say calcium because it is abundantly available in nature. Lime, cement, etc. I can always add so that the calcium ions I can give for this clay mineral to attract. Lot of calcium ions when I give, it also becomes a preference cation, right? Just now I said masala, as I myself intentionally putting that so much of calcium, that becomes the preference. At least it will stay with the clay unless the environment is changed to a greater degree. So like that only we have to silence the system. At the same time, we have to be very clear, we are not changing the mineral, friends. Please understand. These hearts are already transplanted, they are like that. Now we are not doing anything. On the surface only the ointment is being applied in the form of stabilization, right? To satisfy the negative charge. That is how we have to understand our stabilization techniques. Yeah, of course, all these different clay minerals. This is, of course, mactite means montmorillonite only. In fact, vermiculite is again more swelling than montmorillonite, but fortunately, in nature, the content of vermiculite is less compared to the montmorillonite. This is how you see clay particle surrounded by a thick water film. This is the problem with this clay. Once all particles are having this layer of water, then two clay particles will never touch each other as long as they are saturated. Then the very effective stress principle remains questionable. Please understand. The effective stress principle and bearing capacity, what all we understood for conventional soils, if you blindly apply to these type of soils, it is not correct. Because in this situation, the other particle also has its own water fill, and ultimately where is contact between them? When there is no contact, where is stress transfer, where is effective stress? All that principles you cannot blindly apply to this type of systems. That is why Herzog himself said, in case of highly plastic clays, my theory of consolidation is doubtful, and also effective stress principle. Under remediation, clays are giving problem. In case the thickness is thin, remove that, be happy. Okay, so that is how soil replacement concept was given. As long as the thickness is shallow, within 1 meter, happily we can remove it, replace it by good soil, then all the problems were nullified as a civil engineer. Of course, other idea, this clay, just now I have said, despite all the aggressive swell potential it has, it is only the environment that triggers the swelling nature. If at all I can create an environment such that the clay can remain in one condition, then also it keeps quiet. Philosophy is excellent, but in actual practice, this technique was not that successful. The philosophy of this is, anyway, it is attracting water subsequently after construction and again undergoing volume change. Much before construction itself, we apply water, then it will be saturated, construct, close it, then that high degree of moisture content As long as it is there, it will not undergo higher volume change. Philosophy is correct. But however, in actual practice, there were several problems also because here it is not only that volume change, bearing capacity is affected. The moment you pond all the area, it becomes slushy. The required bearing capacity also we will not get. Another problem. And in fact, some of the researchers have reported this high moisture content will not remain there only. It can pass through to the other zones where the moisture content is less. Again, it triggers the swelling there. Ultimately, that is why this technique is not that popular across the world. Yeah, and of course, moisture barriers for ordnance factory buildings also we have suggested. In fact, this type of approach, wherever we have suggested the quarters to be repaired, first of all round, we suggested to provide an apron like this. And while constructing aprons, especially when black cotton soil is there, this edge can be lifted more than this edge. Then unnecessarily, instead of helping our building, it will trigger more swelling if it is reversed like this, and all the rainwater will enter into the foundation now. So in order to overcome that, we have suggested here to have a nice joint with some material, bituminous felt or something like that. And in case if it is opening, every time you please close it. We have suggested like that. Again, the slope, everything we have suggested such that quickly the rainwater goes away. You see, in case of black cotton soils, the problem is any water that could enter quickly into the foundation system, definitely damage is inevitable. Ultimately, the soil will be saturated. There is no doubt about it. But when the soil is saturated slowly, then this soil itself develops its own remedy. That is what is called cohesive bonds. The moisture films under slow entry of water surrounds the mineral particles, developing the cohesion bond. It will hold the particles. Quick ingress of moisture, which allows the water to enter into the mineral layer particles, triggers the swelling. That is the philosophy explained by Professor Katti of IIT Bombay while explaining the CNS layer concept, cohesive non-swelling layer. We will see little later that. So that is how, friends, whatever that technique we may suggest, we have to be very careful and clear. Blindly, if you do something, it may unnecessarily damage more than its help to the stability. Of course, for pavements, etc., this type of vertical moisture barriers are suggested. Of course, Professor Chan, what he has written, yes, all these moisture barriers can slow down the process of saturation, but ultimately everything will be saturated. But just now I said, despite that, the damage potential will be less because of this low entry of water. This is again lime stabilization, cement stabilization, all this again, we have to mix with the soil, plow it, then roll it. Not easy. In fact, recently we were asked to give a suggestion for a rural road in Guntur district for lime stabilization. When we have given that suggestion, in fact, honestly, the contractor has taken our report and started the work. But the whole problem is the IRC suggests that all the soil to be lime stabilized should pass through, I think 25 mm, and 80% of that should pass through 4.75 mm. See this line, it has become very difficult for him. Ultimately, he could not pulverize. Later on, again, we were forced to change our report, indicating that until state-of-the-art equipment could be imported by India, these techniques may be difficult for their implementation in practice, something like that. But fortunately, in the recent times, we could see Stable Road. It is from Germany. That is doing excellent job. In Vijayawada, in fact, for one of the roads near Porangi, we have suggested that there, that machine itself will excavate If necessary, dry it also a little. Then whatever the cement content you suggest, that will be added. And after adding it again compacts, that means all in one. Excellent. After that, we have become little confident to do some stabilization. But of course, as very few people are doing at present, it is little costly, but otherwise, it is very effective. We have seen with our own eyes and convinced. Yeah, this is how. But otherwise, normal equipment and all that means little difficulty is there. Yeah, again, at the end of that, again, it must be properly compacted also. Yeah, this is what I am referring. This road only, degree of pulverization could not be made. In fact, for 2 months he struggled. Ultimately, when the degree of pulverization is not adequate as per the standards, again stabilization remains doubtful. And in case if it is not worked, and we will be blamed and he will be blamed. So then what we have written is, again we asked them to recompact the whole thing as usual. Then 2 feet thickness of the moram cushion we have suggested to be placed on this clay bed, so that based on that 2 feet thickness of the moram, the C bar value was arrived at, and then the pavement design was made and constructed. Okay, in that report only we have suggested, because they wanted to send that report to the rural development ministry. So in that we have written the same lines: until the state of the art equipment could be procured by India, these state of the art stabilization techniques cannot be implemented in the field, something like that. Yeah, this is again where everybody outside asks us, sir, we will place some sand in the foundation, then is it okay? See, normally in some research papers also it is written sand cushion has become effective when you do your research within 1 or 2 years. We may feel it is effective. Beyond that, it also becomes very hard. You see, when it is having some way to accommodate the volume change from the underneath clay, just like cushion it can act. But after few years, it also will be densified and ultimately become very stiff. And along with this lifting, this also will be lifted and lifting the foundation. That is the problem. And at the same time, sand being highly permeable, it also attracts water quickly. That is what I have already said. If anything enters quickly, there lies the more danger. In fact, Mote village in Karimnagar district, some time back, government has built a colony for the poor people. It is all black cotton soil area. So we do not know. Somebody suggested they have gone up to 9 or 10 feet depth. It is all not footing foundations, the continuous foundation. 10 feet depth trench, filled up to 7 feet with sand. They again constructed the footings and come out. After all, they are all single-storied buildings only. So you can imagine top 3 meters, below 3 meters. That is the problem with the clays. Okay, there it seems what anybody can feel. 10 feet, 7 feet sand is there, and the buildings were constructed single-story, no problem, nothing happens. But to their surprise, within the next monsoon season, these walls are above the ground level, is it not? At all the corners, these walls are just separated. That means this wall is pushed this side, this wall is pushed this side, and here through this one can walk also. It is not crack, actually it is a gap. That much volume change took place. Then we were called, and ultimately we have found the mistake. What they have done, the sand question might have worked for some time. We do not know how effective later. But in the very beginning, why it is damaged is that the same black cotton soil they have used in the plinth filling for this below the flooring. On this side, nothing. Then here around 3 feet black cotton soil is present. Then they might have put lot of water also for its own compaction. Normally people put a water pipeline, is it not? Water pipe for the moram or sand, any soil for compaction within the plinth. They might have done like that only. So that may be the reason how just now I was referring the lateral swell pressure could be tremendous, against which unless precaution is taken, simply it can damage. Here, almost all the homes were broken like that. We have simply written all homes constructed under this requires reconstruction, and we have suggested our own way of dealing with the foundation. Not at all the sand question and anything. Pad footings plus the grade beam, and below the pad at 10 feet. What was there, they also did not record properly. So understand this data clearly. In that case, we have suggested pad footing plus CNS layer. Moram is also available. So moram question we have suggested with extra 1 feet depth on all the sides. Okay, and friends, that is how one has to be very clear. In case sand, somebody pesters you, the differential free swell index, if it is just 30, 40, liquid limit is just 40, something like that, then it may work. Because some people claim from Guntur, sir, it is all successful. Maybe in that low swelling type, this may work. That is only there. But otherwise, if at all any other granular soil is available, use that. Why to use the sand? At the same time, now sand is more costly than other soils. Yeah, this is what the CNS layer technique proposed by Professor Katti. His entire philosophy, of course, 30 years he did research on this one topic. See, just now I have said, when water enters slowly into the system, these water films surround the soil particles. When these water layers are surrounding the clay particles, Cu is written, you see, that means cohesion is formed. And these water films are in tension. So these cohesion bonds are formed, and this opening between the clay mineral particles will be held by this cohesion developed. This is what he has written as self-stabilizing cohesive bonds, right? See, that is why only when something is a problem, and if at all the doctor is already there, it is always wise to use the doctor within rather than inviting outside doctor, is it not? This is what actually this philosophy. Then what Professor Katti suggested, black cotton soil may be there. Over that, put a moram soil most closely satisfies the CNS, cohesive, non-swelling. It must have some cohesion. At the same time, by itself, it should not have any swelling property. That is the cohesive, non-swelling layer. So, a moram soil mostly satisfies if you keep 1 meter thickness of the moram on the black cotton soil. This moram also will not allow the rainwater to quickly enter into the subgrade clay. Any water that enters slowly enables this clay to develop its own stabilizing bonds. Excellent. That means we have to facilitate the system to help itself. That is why these are reinforced earth, and this type of techniques, they are all called active systems, right? Retaining wall, passive support. Only when the wall moves, that the soil moves, the wall rescues. Otherwise, wall just keeps quiet. It also will not stop the movement of the soil. So that is why they are all from outside. Whatever the help you are giving, it comes under passive support. If you enable the systems to develop their own stability, then they are called active support systems. Here also the same concept, friends. This technique enables the clay to silence itself. Excellent. Right. So in this direction, though conceptually it seems to be very nice, but in reality, again, there are problems in the sense the material specifications are not that easy to be satisfied. In Telangana region, as we are here, mostly we are fortunate that moram soils are satisfying to the extent possible, though if not exactly to some extent. But that cohesion must be there. That cohesion is being satisfied, though other contents are not that satisfied. And again, here also, Katti's suggestion is very difficult to follow. You see what he has suggested, if at all you are constructing this home, all the area below the building, all over the plan area, it is to be excavated around 2 meters. Then CNS layer is to be compacted by 1 meter, construct your footings, then again fill back. Very difficult. So anyway, that is how, friends. Oh, at present, based on our experience, what we are suggesting, in case this is to be adopted, 1 feet extra on all the sides of the footing, we are suggesting, right? Construct like that. And minimum 1 meter thickness. And here also this clay, everything will be there. Anyway, basement filling, it can be made using the same CNS soil so that mostly it will be free from cracking. And of course, here if the black cotton soil has high degree of swelling, still it is better to supplement two techniques instead of only one. Here, simply put some few bore holes, either calcium chloride or even lime. It can be filled, and then filling here the moram soil will be useful. Of course, above the ground level, right? Above the ground level, to have the plinth, that plinth filling must be using the cohesive non-swelling soil layer. Below that, anyway, clay is present. That is how we are running the show. Little problems are coming, fortunate. At the same time, most of the Indian soils, they are not that aggressive. Very few pockets are present. When we are too blind to address the problem, then only they are giving problems, but otherwise, most of these areas are okay, right? That means they are moderate swelling only. Typical black cotton soils, I normally call our Indian black cotton soils. Right then, friends, that is how we are doing like that. Depending upon the degree of swelling, you also can do that. 1 feet extra on all the sides beyond the design size, and plinth filling anyway, moram soils are to be adopted. And on all the sides, yapron is to be provided with a proper joint here. You should not allow this apron to raise higher than the inner side. Then also it will be a problem. Raft foundation is another idea. In fact, this type of technique was widely used in Africa first time, and everything was nice. The concept here is like it is like a rigid plate, and all the partitions, everything see now so nicely built. And even if something happens as a whole, everything will move, nothing will be damaged. Conceptually excellent. But then first time when they do not have the idea of the connections of the municipal supply, water supply lines, sewage lines, etc., they were all damaged. And ultimately it was suggested, I think Professor A.B. Williams, he was the consultant for this, goose neck connections. We also study that in our building construction. Such goose neck connections will facilitate, they are flexible. These movements can be facilitated by that goose neck, right? That is what he has suggested. Then at least okay, even if there is some tilting or anything, as a whole, the building will be safe. But cost again, too much. That is another problem with this raft foundation. If it is a lightweight structure, again, all the money will go to cast this raft only. Ultimately, we will not have any money to construct our home. That is the problem. So here again, you see, only don't think that only building and its foundation. Sometimes the slabs on the ground, basement floors, all this will come under that category only. Slab on ground concept. All these flooring slabs will be placed on the ground. You see how they are subjected to damage. Exactly at 0.6 to 1 meter distance, all along across the world, this type of failure was noticed. So that is why Professor Chen suggests at this location, 0.6 to around 0.6 meter, if you provide a joint here, there itself it will move. At 0.6 meter distance, provide a flexible joint so that it can slide along that joint, right? So this type of failure can be avoided in that case. If at all we have sufficient money, it is again better not to depend the slabs on the ground rather than this type of slab on ground. We can go for structural floors also. Okay, so here again, when the slab is to be constructed on the ground itself, there are some techniques suggested. Don't directly place all the slab on the ground. Inside, put some farm work to have this type of honeycomb holes, right? That means the swelling, if at all it is there, it can be accommodated into this opening rather than exerting on the floor slab. That is how these type of designs were suggested in case slabs on expansion soils are inevitable. Yeah, this is what I was referring. Slip joints can be provided here or at 2 feet distance. It all depends again. Again, below the grade beams also this void, even in our underground piles, all along the grade beam, below that 10 centimeter air gap is suggested by the code. How to maintain? Here, of course, they are providing in other countries concrete panels, something like that. In India, easily we are able to do that by putting the bricks. Okay, brick on edge we can place on both the sides so that this void can be maintained. Yeah, this is what I was referring. See the connections, water supply, when this floor slab is lifted up, this is actually subjected to distress. And here the whole wall itself is subjected to buckling because of the lifting from the floor slab. So it is better to have a slip joint here or here. Then this pressure will not be exerted on this superstructure. Yeah, even for partition walls, etc., we should not be too blind. Simply, if you construct a partition wall between the ground floor and the upper floor, the moment this floor slab lifted through this wall, enormous pressure will be exerted on the roof slab. So, in order to overcome that, simply this type of joints were suggested, right? So, even if it moves, it doesn't harm the superstructure. And these are some of the ideas suggested across the world. All around the building, in case there is some problem, these grouts can be injected. The range of grouts are varying from organics to lime to calcium chloride to recently even some other chemicals also are developed. So based on the requirement and efficiency and upon the consultant suggestion, such chemicals are being injected into the foundation in case there is a damage to the structure. As a remedy, actually, that is being adopted all around the damaged structure. This type of stabilization is being attempted under pressure injection. Of course, here also the limitation is clay only when it is dry will have desiccation cracks and absorbs the chemical grouts. When it is wet, nothing you can inject into that. That is another problem. Yeah, these are all some of the remedial suggestions suggested. Be careful and always provide. Sometimes what happens, the partition need not be supported on the flooring. It can be suspended from the roof slab also. In that case, accordingly, the slip joint can be provided wherever that is required to accommodate the movement. You should not be blind. Somehow everything is to be taken care. See, this is what I was referring. In case of continuous walls or continuous footings also, give a gap. Don't provide it continuously. So if that is the case, we to really go for this type of construction and giving gaps and all that. Go for the pad foundation itself. Provide a grade beam here. Okay, so that is wise rather than this type of voids in between. Yeah, this is how void below the grade beams are being maintained, precast concrete, retain all that. But in India, we are using simple bricks enough also. We can maintain easily that gap. And here again, you see this gradient is again very important. Just now we were referring, and here the precautions are all given. Capillarity, if at all it is to be broken, put large size aggregate. Then, of course, a geomembrane or something like that, the moisture content should not go up. So all these precautions are again given to protect our floors. This is another idea, you see, in case whether that natural ground system will really allow or not, a mound is formed, and on the top of this mound, a geomembrane is placed. Over that, good soil is placed, that is non-expansive soil, and on that, a raft foundation was constructed. You see, that means just in the beginning I said it is the environment that triggers the swelling. So here all these slopes are so maintained that the water can easily go away from this zone, then it may be safe, right? So that is how this type of ideas are also being used, especially when the degree of swelling is too severe. And all the water supply sewage lines also are well within the non-expansive soil. Yeah, this is what sometimes a geomembrane also can be supplemented. So in fact, in Hyderabad Ordnance Factory, we have not suggested this geomembrane because that much accuracy they may not follow. Ultimately, we do not know what happens. On the name of adopting this geomembrane, they may compromise the other quality. Instead, we have suggested them to place 2 feet minimum thickness of the CNS soil over that. After removing all the grass, slope it like this, and again at the end, if possible, give a trench of 1 feet thickness and put all this aggregate so that rainwater will be collected and it will be discharged into the street drain. Something like that we have suggested. Yeah, now let us see some of our personal experiences. This is actually the flood bank constructed for Singareni Collieries, about 5.6 kilometers long, near Ramagundam. The height is around 5 to 6 meters height. At one place only it is around 7 meters, otherwise 5 to 6 meters is the common height. This was constructed during 2000. After completion of this flood bank, immediately after the completion, within one season, all the embankment is severely cracked. It is all built only of black cotton soil because at that location no other soil is available, only black cotton soil is available. To that extent, in fact, we have given the technical report suggesting that it can be used, but with a protection layer of CNS layer. Accordingly, everything was done, and ultimately, this is the situation. Then you see, uneasiness will be there. The payment was stopped to the contractor because of the severe cracking. Subsequently, once again, we were called to the site. Then we have suggested like this. You see, this is all a very natural process. It has reflected what all that is truth. If it is not reflected now, tomorrow it can reflect, right? Instead of penalizing the contracting agency, let it be closed repeatedly with the same CNS material. Within 2 to 3 seasons, the whole system will come to its own self-equilibrium. Then this cracking will be stopped. This is what we have suggested. See what we have suggested. We have to give some time so that this clay you have excavated, mixed with water, rolled it, something like that. Again, raining was there, water changed, content will keep on changing. But after some time, it will retain its own equilibrium moisture and tries to be in silence. We have to enable it. So whenever cracks are formed, immediately you close them using the same soil. If you do repeatedly, after some time, this will attain its own equilibrium moisture content. Exactly after third year, this crack formation was stopped. Right then, friends. So this is how our fundamentals always helps. We should be very clear of our fundamental soil mechanics learning. Then all this also we can understand. Of course, mat foundation, just now we have seen costly. Of course, failure will not be there, except that pipeline connections, if at all they are taken care by gooseneck connections. But for single story buildings, etc., I think the owner will lose all his money only to cast this raft. The moment you are calling raft, the thickness you can imagine minimum half meter to 0.6 meters. How many roof slabs you are putting in that foundation, you can imagine. Okay, around half a dozen. Then, of course, this suggestion was also made compaction control. That means what is the truth is black cotton soils, the degree of swelling depends on the density. Philosophically, if you adjust the density to such a level that the amount of volume change is less, it is excellent, philosophically okay. But however, in the actual practice, how much less? Is it really possible? And if at all it is too less, also it will be subjected to again subsidence. All problems are also there. That is why in a country like India, I do not believe this and never we have suggested this. Rather than our approach is a little different. Using other techniques, we are handling the problems rather than this compaction control. It is very critical in this country and our contracting agencies, everything. Mostly they will engage non-technical people. We cannot have that much sensitive control here. Surcharge loading, of course, here, if the swell pressure is say 10 ton per meter square, if you keep 10 ton per meter square, it can remain silent. That is the philosophy. But then here also the problem is sometimes in some locations that was a success, but in certain locations that philosophy did not work. The whole problem is here 10 ton per meter square you have determined and kept the foundation load exactly like that. But again, underneath, if there is some other layer which can have more swell pressure, then that becomes a problem, right? So that is how this technique, if at all the soil is not having uniform swelling nature, then also it is a little doubtful. Then stiffening the superstructure in the sense RCC bands are generally provided at different locations at the window level, top of the window anyway, that lintel is cast, that lintel will be continuous so that at different levels when this RCC bands are present, the crack propagation can be controlled. Only that to that extent. So in fact, extensive research we have taken up at NIT Warangal to understand the concepts and again develop the techniques as remedial techniques against these swelling problems. We have selected a site on the campus. Fortunately, our own campus is black cotton soil covered, so we need not confine to our laboratory. And I have gone to the field. Almost all this work was done in the field. And first time, swell pressure is to be determined because if you look at any literature, almost all designs are based on swell pressure. So field swell pressure we have found first for the selected site. Yeah, this is how at 1.2 meters the test plate is arranged after placing little sand, and this test was done by constant volume method. Just now I was referring the consolidometer test where the volume change is fully allowed and again it is consolidated back to its original volume. Here it is not that procedure, it is another procedure called constant volume in the sense, see water is being fed from the top. As and when the dial gauges are moving, additional load is applied through this proving ring to bring back these dial gauge readings to the initial reading. Ultimately, whatever the load that is recorded divided by the area is the swell pressure. Like that. Again, in this work, we have done the comparative work between the lime and calcium chloride, because the philosophy of lime, you see, 1.25 gram of lime is only soluble in 1 liter of water. That means how much concentration of calcium we can really have in case of lime stabilization. So with that gap in that concept, we try to use as an alternative calcium chloride in place of lime, because calcium chloride being strong electrolyte, whatever the concentration I can have, and it is highly soluble, right? Then you may ask a question, if it is too soluble, it can be washed away also. See, that is how we have to be very clear. Just now we were referring clay particle surfaces are negatively charged. Once they hold these cations, either from lime or calcium chloride, after all it is calcium, it should be held by it. In case of any chemical environmental change, that replacement, if it takes place either for lime or the calcium chloride. That is how we have convinced. And again, here also a trench was ponded with calcium chloride, and at different depths and radial distances, the samples were collected and again tested for their index properties and cell pressure. And interestingly, between calcium chloride and the lime, there is a lot of difference. Lime, you see, the problem is away from the borehole, it could not travel much, only through the cracks. This experimentation was done in summer. When we have poured the lime slurry, it could simply flow into the cracks only. Later, of course, we have given sufficient time, but still the diffusion from this crack into the clot is very minimal. That is why, see, beyond this 1 meter, 1.5, the variation is almost negligible. But whereas calcium chloride could enter into this clay bed, because it is like water only, right? Salt water like. Yeah, this is how we have measured the heaving of the ground also by placing the stone slabs on the ponded test trench. This is only around 32 mm, whereas the original ground heaved up by 112 mm. Yeah, this is another experiment where to simulate the canal linings, the same trench was excavated and it is lined. On one side, calcium chloride is used, and other side, lime is used. Then, interestingly, on the lime side, this lining is cracked, right? That is again supporting the claim that its effectiveness is doubtful. And of course, here, comparative statements, you see, unstabilized, lime stabilized, calcium chloride stabilized, right? Calcium chloride could effectively reduce the volume change below the lining panels. And of course, the clay was analyzed for its minerals, and here we have noticed montmorillonite is present in the clay. This is actually what I was referring. Exactly, if we have to say, we have to do the mineralogical study only. Then, again, another idea what we have floated, CNS soil is not available at several project sites and there is a compromise. And wherever there was a compromise, then some failure took place. Instead of that, why don't we make the CNS soil from the same black cotton soil? Okay, one attempt, nothing wrong in that. So to that extent, what we have done is that the black cotton soil is excavated and again pulverized, mixed with different proportions of rhesus cash and calcium chloride. And to our understanding, you see 0.5% calcium chloride and 8% rhesus cash has given almost zero swell properties. And even I think 1% calcium chloride, 6% rhesus cash also has given the same thing. So why don't we then try to have this type of mixes so that that itself can be directly used as a CNS material? That means The same can be addressed by the same homeopathic law. Black cotton soil is a problem, make the medicine from the same thing. That is how, friends, this is what we have tried. And here, the CNS soil specifications, these are all given by Professor Katti. And for the material just now I was referring, you see, 0.5% calcium chloride, 8% rhesus cash to the black cotton soil. These are the properties. Interestingly, most of these properties are now lying in the range, and the important property in the CNS soil concept is cohesion. That cohesion you see here, this is only recommended by Professor Katti, but to the material what we have prepared, it is having 1.2 kg per centimeter square, and it is non-swelling. Just now in the table we have seen swelling and swell potential nil. What else you require? This is more means it is able to develop cohesive bonds very effectively, right? So based on this philosophy, we have experimented few panels, pavement panels we have constructed using this prepared artificial CNS material. We have called it as CSS soil, chemically stabilized soil as CNS soil. Right, and friends, in fact, all these works were published in ACE. Yeah, that is what is rolled in layers. Then panels were cast, right? So again, stone slabs were fixed, heave measurements were made. And this is another attempt we have made on Kakatiya canal slopes, where the lining panels were cast with different treatment alternatives. Let us see what we have done. Here, these are all some of the experimental sketches selected. Then the same CSS soil concept I have used in the pavement construction. Here also we have prepared by pulverizing, then mixed with the rhesus cash and 1%, 0.5% calcium chloride used for some. Sand we have used. Then, in fact, at this location there was a problem of CNS layer. They are going for rock dust. Okay, as in one of the alternative we have used that also. So what all the possibilities, everything we have experimented here, right? All these panels were completed like that. And for some panels, that is what we have suggested. Multiple treatments are more effective. Okay, that is what we have named them as hybrid systems. Combine two instead of one. Some cushion plus tension piles, right? This is how also we have experimented on the same slopes. These are all, see, the different materials, how they have performed. CSS soil, chemically stabilized soil I was referring, black cotton soil plus 8% rhesus cash plus 0.5% calcium chloride, it is doing much better than any of the other materials used as cushions. Traditional Moram cushions, even 1 meter 0.5 used, more heaving is taking place, but for the same thickness, the heaving is very less. Okay, then stone dust, you see, when they say, sir, here CNS soil is very difficult and we are going for stone dust, when we have used stone, it is like sand only, then water could easily enter into that and high amount of volume change is taking place, right? So, but you can understand here, as there was no CNS soil available for few stretches, the department allowed to use this rock dust, and ultimately for I think half kilometer to 1 kilometer, continuous crack is formed in the lining like this, right? That is how the sand, stone dust, etc. are not at all to be used in this type of soils. And this is what another idea we have made. Underlaid pile foundation is popular, but then difficult. Sometimes bulb formation is always doubtful. Instead, what we have suggested, go for footing foundation only because it is more convenient to the people. Connect this footing to the tension pile. Simple. What all the uplift pressure that is exerted can be countered by this. And of course, it is not simply by the shaft resistance, but our philosophy is when it is subjected to swelling, the horizontal swell pressure just now I was referring is several times that of the vertical swell pressure. That means this itself will hold tightly during that swelling process. And in that critical state, when it is holding with high degree of lateral swell pressure, the volume change will be reduced because expansive soils are sensitive to the initial restraint. That philosophy we have used here, right? Everybody can read any textbook. Surcharge is again very effective against the volume change. The same surcharge is being provided here because of the initial restraint, because of the lateral swell pressure on the shaft. And of course, subsequently, the anchored granular pile concepts were come, and that also we have experimented. Why only straight shaft and smooth surfaced concrete? In that, in place of that, if you could place aggregate and ram it, highly rough surface can be formed. Okay, so this aggregate can develop interaction and interlocking with the sides of the borehole, and the pull-out resistance will be much more than that of the concrete piles. In fact, when we have conducted the uplift tests, the uplift resistance is double that of the straight shaft piles for this anchored granular piles. Yeah, of course, underground piles everybody knows, but however, the difficulty here is only the bulb formation. If it is not really formed, then the whole design will go wrong. Yeah, this is the site where we have experimented the tension piles. Yeah, with different lengths and diameters. Yeah, in fact, for some of the walls, we have suggested to use the tension piles when they were used. You see, no single crack is formed. And for the TV tower foundation, tower structure near Warangal, we have suggested this piled footing for around, I think, 800 meters long compound wall. There it is all black cotton soil, but they wanted to go for some stone masonry. For that, we have suggested like this. Of course, somewhere columns in between stone masonry. That is how we have suggested them. Simple idea, and even now, no single crack is formed. Around that private buildings, you can see some cracks. And in fact, here it is a little modification to that. For some of the residential buildings also, the similar idea we have given near our institute guest house. One private owner, when he approached, we have suggested below the footing, two tension piles we have suggested, right, like this and cast. For the compound wall also almost similar idea only. Here again, below the footing, again two we have suggested, okay, instead of one, because in case of any volume change unnecessarily, he will be in trouble. So reposing confidence on our technique, he has used, and fortunately no cracking was subsequently there. Yeah, this is what I am referring for that TV tower station. For that also similar design, of course. Okay, instead of that, here CRS masonry was used, and occasionally some concrete columns are also provided in between to break the continuity of this masonry. Yeah, this is that wall. Yeah, this is for the anchored granular piles. These are the central anchors. Around that the aggregate. Okay. Central anchor plus aggregate. This is the anchor and aggregate. This is again rammed. Because of that, it develops thorough interaction and interlocking with the sides, and excellent uplift resistance will be mobilized. That is only required against the lifting. So ensured. Here the very difficulty is its installation, because it is not still mechanized. The moment it is mechanized, it will be very useful. And because we ourselves have felt uplift capacity is much more than the straight shaft piles. And friends, in fact, for this part of the work only, we were recognized by the Institution of Engineers London in 2015. This work is considered to be one of the most popular work from India. Okay, again, in continuation of that, we have also experimented. See, ultimately, whatever the research we will do, we have to demonstrate to the reality as closely as possible. Compound walls were constructed demonstrative, some 3 meters height, and then adopted different techniques. And ultimately, you see here, I think here for one wall without any treatment, for another wall 300 thick CSS cushion. Just now I said the same black cotton soil is modified with 8% calcium rhesus cash and 0.5% calcium chloride. That cushion was used. And in another wall, 4 numbers of 1 meter long, 100 diameter tension pile. And again here 3 numbers, 1 meter long, 150 diameter tension piles. For all these walls, these variables were used, and again when heave measurements were made. Interestingly, any technique you adopt, the volume change is within 20 right? This is what actually code also allows, below 20. This is also a study we have carried out at our campus near our guest house. See, I said it is all black cotton soil area. Here our interest was to prevent the reflection crack formation. Pavements, when they are built on clay substrates, this clay will be subjected to desiccation cracking, and this desiccation cracking can spread to the surface, extend to the surface. Right? That is what is called reflection cracking. In order to mitigate that problem, what we have studied, okay, what all the techniques that are already prevalent in this world against these volume changes, let us experiment. Then relatively we will understand which is better. And of course, Geo's textile also we have used. Somewhere let us see now what we have done. In one case, 0.3 meters thickness of the sand, then a geotextile, and 0.3 meter thickness of the moram. This one type. For that, again in another stretch, all 2 feet thickness is only moram. In another stretch, the black cotton soil was excavated up to 2 feet thickness, 10% lime was mixed and again compacted, and again 2 feet thickness of the moram was placed, and again the system is closed. Like that, variables were different variables were used and heave measurements were taken. See the situation now. Propagation of subgrade cracks to the surface of 60 centimeter thick moram cushion over BC soil subgrade. This is what IRC says. In case of black cotton soils, put around 0.5 meter thickness of the granular layer, determine the CBR value of this, design your pavement based on the CBR value of this placed soil, and forget about the black cotton soil. But this is the fate of it. And in the other case, 30 centimeter thick sand cushion and 30 centimeter thick moram. Just now I have shown you here. You see the fate of it, broken like glass, right? That means sand, the moment it is provided, it allows quick ingress of moisture, and ultimately lot of volume change can be possible and movements are possible. And here geotextile reinforced 30 centimeters thick sand cushion and 30 centimeter moram. Even when geotextile is placed in between, that also could not prevent the cracking when sand is present. And here calcium chloride, when it is used, volume change maybe in terms of swelling it can control, but the shrinkage cracking cannot be controlled. That is the problem here. Okay, the ground is stabilized, and IRC suggested CNS cushion also was used, but still cracking has become inevitable. And 10% lime stabilized and 60 centimeter thick moram, still cracking is inevitable. And 6% cement stabilized the subgrade with 60 centimeter thick moram cushion, even then it is cracked. Ultimately, see the magic. The smart material geotextile, when scientifically placed it could prevent the reflection cracking. What was done here? Instead of stabilizing the ground or doing anything, directly after removing this grass, the geotextile is placed over that 2 feet thickness of the moram soil is placed as urged by the IRC. Now, no single crack is formed, you see. That doesn't mean the ground is not cracked. Must have been subjected to desiccation cracking, similar to the other structures. But however, as our geotextile being strong in tension, it did not allow that crack to be reflected to the surface. Right then, friends, that is how geotextiles or geosynthetics are considered to be the smart materials. They are light in weight, but they're very effective. Smartness comes from lightness and effectiveness. That is why geosynthetics also can be experimented in the expansion soils along with our traditional stabilization techniques. Yeah, of course. So these are other clays. Soft clays have their own problem. Oh, not only black cotton soil, soft clays also have their own. Whenever clay is encountered, suitably we have to be very careful. Here, in fact, in this soft clay, strip drains were used and they have not given time. And when you do not give time, see, after all, after taking meals, 3 to 4 hours time is to be given before it could become energy. Otherwise, again, it becomes a problem. Same thing is true. Even when you are using the technology, if you do not give time, the ground cannot absorb the technology. And unfortunately, here, no consolidation settlement, nothing, bearing capacity failure took place. And these are some of the other clays, friends, shale clay. Because don't think that only black cotton soil is a problem. Other clays are also problematic. Then suitably we have to address. This shale clay, in fact, in Adilabad district, this type of clay, almost their entire in the entire district, wherever the project they have built, this is the only strata I could see. Here the problem is through these joints, water could simply percolate up to few kilometers down the reservoir. You will not see any seepage adjacent to the dam, but far away you will see the seepage. And then, of course, here grouting, etc., were tried at several projects, but ultimately the seepage could not be prevented. Then, what I have suggested is to place the clay blanket of at least 1 feet thickness on entire reservoir area, roll it. Subsequently, most of the reservoirs became healthy. Right then, and here, in fact, this type of shale clays have their own problem. I said, Komaram beam project actually it is. The depth of excavation for this canal, you see, more than 20 meters. Because immediately adjacent to the reservoir formed Komaram beam project, the canal excavated is close to the hills. So there it is like a ridge. The canal depth is too much there. Okay. So the top it itself is about 150 meters. Immediately after excavating the canal, all the slopes were repeatedly sliding and falling. And here, interestingly, they require only 5 meters width and the depth of water, they said, I think 2 meters only. For that small area of flow, they have done this much exercise, and despite all that, repeatedly it is collapsing. They could not succeed. Then, of course, they have invited the experts from Bangalore and elsewhere. They have suggested their own way of dealing with the slopes. Ultimately, based on some past experience, they know me and asked me to visit the site. Then ultimately, you see, I have given not a geotechnical solution, but a structural solution. It is very difficult to handle these slopes. Let us do not handle. Anyway, here also there is no more space. Already hills are there. You cannot excavate and make them flat. And on this side, agriculture fields are there. They do not give any more land. So instead of handling all this, simply grow some grass and something like that here. Even if it collapses, no problem. Provide a concrete box of the required area like a tunnel. Successfully they have built, and ultimately now it is all right, friends. See, this is the situation of the shale clays. This is Pranaheta Chevella project. Okay, these slopes are again falling. This clays, the problem is they have their intrinsic planes of separation. From outside seems to be very nice, but closely if you see that the plane is already separating, and during the rainy season it allows water and simply the whole slopes can slide, right? See, this is how the structure actually somewhere here, it is all slided towards this. The excavated canal, actually the base width is around 71 meters. The depth is varying, of course, depending upon the terrain. Adilabad, you must have seen, it is a highly undulating district. So, okay. So the excavated canal has become like a channel, you see, natural channel. For this, all these types also, we have given some structural solution rather than geotechnical solution, because geotechnical solution seemingly more costly here. Okay then, friends, thank you very much for your patient listening. If you have any, don't say queries or something like that, clarifications, we can have some discussion.
Yeah, quickly we can have a few questions from the participants. I hope your presentation is very clear, but still, if they have queries, they can discuss.
Good evening, sir.
Tell me.
Myself, Bipin Prajapati from Kennedy Sultanpur.
Sir.
So, I want to know if we find some expensive soil with certain problems, then what should be the procedure or to select the material for stabilization, such as fly ash, you have suggested some cementitious material, or you can say use foundry sand or other than. So, what should be the basis of selection? Is there any selection procedure or rejection procedure or any guideline or flowchart?
Okay. Sir, I could understand. It seems in case black cotton soil is there, how to stabilize using different materials when available. How to select each material. Is it that the question, sir?
Yes, sir.
Okay. See, normally when black cotton soil is present at a particular construction site, we have to be very clear and open-minded and should not invite just only the stabilization. If you can avoid the stabilization also, it is good, sir. First of all, that is why we have to think like that, because any stabilization process is costly and also laborious. Excavation, mixing, recompaction. In that process, again, if anything goes wrong, it may weaken the whole system. So that is why only when it is required. Fortunately, in the last 23 years of my career here in black cotton soils, without that stabilization, I could handle the problems. Somehow, in case it is essential, then we will definitely adopt, but otherwise, better avoid that stabilization. If at all you can avoid. Okay, if at all it is inevitable, then CNS soil can be preferred, sir, rather than the stabilization. CNS soil means nearby that site, if gravel is available, you excavate the foundation pit 1 feet extra on all the sides. If at all the black cotton soil thickness is too much, as per the general procedure, we go only around 2 meters depth. 3 meters we have to go. That extra 1 meter is to be filled back using the CNS soil with extra 1 feet thickness width on all the sides. Then you construct your foundation as usual. Most of the time, we have never seen any cracks in that type of foundation. And at the same time, first that soil is to be tested for its swell properties. Based on that, if you take a decision, it will be more scientific rather than blindly adopting, because all black cotton soils are not same. They have their own degree of swelling. Based on that, if the treatment also matches, then only it will be nice.
Thank you, sir. Thank you.
Right.
Such a nice presentation, sir.
Okay, thank you, sir.
Thank you.
So sorry to interrupt. I have a question.
Amma.
Sir, in most of the residential or commercial apartments or buildings, we see that there are double basements happening.
Yes,
There we see lot of cracks on the grade slab, sir. So,
yes,
what
yes,
do
yes,
you suggest for such? Because we have ponding of water
yes,
most of the times in the monsoon season. So,
yes.
what would you suggest for such problems, sir?
In fact, in Warangal also we have faced with such problems. My simple solution for such problems is the basement slab at the bottom, the flooring. Anyway, it is breaking means you break before it could break. This is the concept I am using. I think you could have understood or you may not be able to understand. Anyway, this floor slab is going to crack either under uplift pressure because of the swelling, or sometimes even people do not give a way for the water to escape. Under both the conditions, these floor slabs are subjected to cracking. And in fact, for one of the building, the breaking of that slab has given lot of damage to the superstructure also. Unfortunately, they have put some reinforcement, and because of this water pressure underneath, that is broken with lot of sound. So, in all those cases, what we have suggested them to provide the joints to allow water to come out easily even when such poor water pressure is built up underneath. So a graded filter like material you can place in a grid pattern, and over that a small cover like a drain that will not be shown outside. Okay, so that gutter will be there underneath and it collects all the water that is coming as an upward flow. It will be collected on one corner. Occasionally it can be pumped out. So that is how we have suggested. And most of the problems, whatever is suggested, it may not be because of that clay. Yeah, when it is two basement depths, by the time the clay will reach its mostly equilibrium state only. But then also it is breaking means maybe the similar problem what we have noticed here. There also that problem may be confused as the black cotton soil problem. In case, if at all that black cotton soil only a problem, 1 meter thickness of the CNS plus the joints also must be provided, because 100% volume change reduction is not possible by any of the techniques. Even what all I have explained so far, 100% silencing is not possible. That we have to understand. That is why Professor Charan himself he has suggested there is no single engineer in this world who could guarantee a crack-free structure. When that is the universal truth, you and me cannot totally silence this clay. That is why, to the extent possible, we have to club different ideas and give the best possible answer. And in our reports also, we should not say your building will be free from cracking. To the extent possible, the whole thing may be okay. Even if moderate cracking is there, they can be repaired or something like that. Like that, we have to make a statement also in our reports, so that it will silence. Otherwise, people may feel this engineer has told all that, and ultimately this has gone wrong, something like that, because that uncertainty is still there. Right,
Thank you,
Amma?
sir.
Amma,
Uh,
right?
Thank you, sir. Sir, I have another question. See, most of the projects coming next to the lake area, so they're closing the portion of the lakes and they're constructing a lot of villa projects
Yes, yes,
residential apartments. So the retaining wall constructions around that lake area is a big problem. So I've seen
yes,
a lot.
yes,
So
yes.
what would you suggest there, sir? So building a retaining wall, even though they're giving the drainages to the retaining walls below, but other than that, any other methods you would suggest them uh,
Okay. This type of
to avoid?
problem we have faced in even our Bhadrakali tank and even in one project in Hyderabad. For this, normally retaining wall construction, once you are making, it requires the solid foundation first of all. The earth pressure, everything secondary. But first of all, we have to ensure that the retaining wall is standing on a firm ground. If they say it is all soft clay, sir, we will just take 2 meters and construct, means that retaining wall will suffer. We should not allow for such retaining wall construction. Of course, fortunately, what all the projects I have handled, within 3-4 meters depth, moram soil was there. So even when the height became more, we have suggested them to go up to the moram, cast the foundation, come up. And with respect to the lateral swell pressure, when the height increases, it becomes uneconomical. Normally, half Ka gamma h square. When h is more, the pressure is more. When pressure is more, the design will be uneconomical. There is no doubt about it. Then what I have suggested, whenever the heights are more, in the backfill, some 10% cement we have suggested to be filled. Then the material that is filled behind becomes mostly self-stable by itself. It doesn't exert the designed lateral earth pressure. So that is another idea we have given to our clients. And sometimes we have again clubbed with the geotextiles. And in fact, for one of the stone crusher project where the compound wall is totally collapsed, there again we have suggested like this, a compound wall and the RCC beams from the compound wall into the fill, and at the end there is some bend, 30 centimeters bend. All, see, that is what I am telling. What all we are learning, it must be channelized, not that ready-made answers will be given. Gradually, based on our own experience and learning, sometimes all these ideas we can use. There is nothing like exactly this is the problem and this is the medicine, like it is not available. Yeah, especially when we are entering into the difficult areas of consultancy, we have to have some multiple levels of understanding and knowledge. Nothing wrong. In the beginning, we may not have. All of us studied the same thing. So we can consult each other. Nothing wrong. If you do not know, you can ask somebody. They can also share. After all, nobody will hide this type of knowledge. What is there in this? If I know, it should be shared. Okay, Amma? So like that.
True, sir. Thank you so much.
We will handle like that.
Thank you, sir. Thank you. And about your research work also, I was very happy to see that. Thank you so much for giving us so much of information after your research, sir. Thank you so much.
Thank you, Amma. Thank you.
So if there are no questions, no further questions, I thank Professor Ramanamurthy for his detailed presentation on expansive soils. He has explained the concept that is the swelling mechanism. So right from clay mineralogy, right, he has explained how to identify expansive soils, what are the methods, right, what are the techniques you can think of adopting for supporting structures and for laying pavements, right? So all these things he has addressed. So coming to foundation soils, he was mentioning that you excavate the soil up to 3-meter depth, and then place 1-meter thick CNS material, and above that lay your foundation. So that works well. Even right in Visakhapatnam and Srikakulam area where expansive soils are there, right? We have been recommending that. So not only the question will be effective in suppressing the swelling of underlying soil. Indirectly, you are transmitting your loads to the soil which is falling below the active ground. That is more important. So this is the effective method of supporting foundations. And coming to payments also, as Professor Ramanamurthy mentioned, placing a geotextile and keeping a minimum 60 centimeter thick moram layer and laying pavement will solve most of the problems. Instead of trying mixing of chemicals into clay, uniform mixing, again, everything will be difficult. Not only it involves cost, but effectiveness we cannot guarantee. and he has introduced you to the topic of going for conventional foundation shallow depth and connecting it to a tension pile, right? So that is also a good concept. He has demonstrated with case studies which he has handled, right? So he has used it on many occasions, right, to support foundations in expansive soils. And he has shown us, right, the details of various test track studies, right, to study the effectiveness of questioning, right? So that is really wonderful. Right. So thank you very much, Professor Avanamurthy, for sharing your research study findings and for making it convenient to deliver the lecture in a very detailed manner. We hope to see you in future also for helping the teachers of engineering colleges and practicing engineers to enhance their knowledge level, particularly in dealing expansive soils. Thank you, sir.
Okay, sir. Thank you. Thank you then. Thank you
Sorry,
all.
sorry to disturb you, sir. Sir,
Tell me.
please share your mail ID, please, sir.
Okay, Dr. Satyanarayana Reddy is having my email ID. He can share.
I'll share once the program is over.
Yeah.
I'll share all the participant details along with the resource person details also, so that you can communicate with them in case you have any queries. I thank all the participants for the patient hearing and for their active participation. So we have come to the end of all technical sessions. We had 20 technical sessions. So as per the procedure of AICTE, at the end of FDP, right, AQIS, AICTE Quality Improvement Scheme programs, right, we need to have a test. So tomorrow at 8:30 a.m. we'll have a test on FDP. As I posted in the chat box, right, you will be given with 20 multiple choice questions and 10 true or false, right? So based on whatever knowledge you have acquired by listening to various lectures, you will be able to answer, right? So once test is over, we'll discuss about various questions that are there, and any other queries we have also we can discuss. And in the evening we'll have a formal valedictory function, and then we'll close our FDP, right? So I thank you all once again for your effective participation. So once again, thank you, sir.
Okay then, right.
Thank you, sir. So good night to all of you. We will meet again tomorrow at 8:30 a.m. Thank you all.